I worked one similar to this yesterday, I think, but I was working a problem where we were looking for the maximum, not the minimum. Now the minimum problem is slightly easier to work, but let's be sure what we mean by the floor function. The floor function is a mapping from the real numbers to the integers, and I really like this notation here. It's a member of what Z. I think that German for Zahlen to count, and so the integers are just like -1, -2, 0, 1, 2. So the whole numbers and the negative counterparts basically. And so it's often called the greatest integer function or the floor function. And just examples are the floor of any integer. We'll be dealing with natural numbers for this one, but that's equal to 3. It's the greatest integer less than or equal to itself, right? But also the floor of 3.9 would map this real number to the value. All that does is supposed to read 3.9 to 3 also. So a key aspect of the floor function is that it's a step function kind of if you look at its graph. Okay. So what we're looking for here is the minimum value of m such that we get this floor of 1167. Okay. And so here's your little m right here, and little m will be a member of the natural numbers. Now this looks a little dastardly here, but if you'll take a look right here, just one way to kind of get you started is where in the world does this number come from? Well, you'll notice that 3 times 17 is 51. And so this 305 right here, let me just come out. I kind of got my way there. But that is the same thing as 300. And that can stump you. I tried to make the numbers nice where you could just by inspection. But this number, 305,100 is equal to 300 times, and it's convenient. I could have, made it harder. I don't want to do that to you guys. All right, but so yes, that's what's going on with this. 300 times this is this middle term, and then that makes you just think immediately of the result, a plus b squared. It's that and the difference of two squares like happen in 50% of all math problems, it seems like. But you have a plus b quantity squared right here. All right, and so that's very well known. You can expand it out. Distributive, it's double distributive property, kind of, if you want to think that way. But you have a squared plus 2ab. Trying to keep it lined up, my friends. Plus b squared. Okay. And so that's all that happened there. And notice that this does add up. 150 in 2017 add up to the desired 1167. And the 2 times the 150 here, this 2 times this 150, it gives you the 300 that we were talking about earlier, right? But you pay the price by having to add 150 squared, okay? All right, and so if you just identify here, you can almost already see the answer without going much further, knowing what the floor function does. You compare this that I'm hovering over, you compare this with this radicand that involves this value m that we're looking for. And this is the formal aspect of it right here. Just like I said earlier, the square root of something squared is the something. So the floor of an integer is the integer back. And just by inspection, we get that this is the minimum. You'll notice you couldn't go any lower, right? If you went any lower, like if this were 149, it would knock it down to the floor level of 1166. Just by looking at this, if 150 was any smaller, this would be smaller than the square root of 1167 squared, and your floor would have to be less than 1167. So it's clear that this is the minimum value. Now, if you're curious about the maximum, I worked that one just the other day. What you could do, and I'll just write this down and see what you guys think about it. If you wanted, the answer to the maximum problem would be this. Just take one away. You need to do that, and that's, if you're familiar with the floor function, that makes sense. And then to that, you're going to add 1968 squared. I'm sorry about that, folks. Let me clear that. I don't know where that came from. Okay, let me erase that. To that, you're going to add 1167. Weird. 1168. How those work numbers? Something made me say that. I don't know what it was though. Freudian slip. All right, so we have this minus 1167 squared. Okay. That would be the maximum. All of this would be your maximum value. And that's kind of cool if you want to verify why that's true. So that's how that would work, folks. Let me know what you thought. I'm probably overdoing this stuff, but I just think floor functions are fun.